Hello, welcome to Socorro's webinar series, Coastal Observing in Your Community. Thank you so much for sharing your lunch hour with us. My name is Abby Wakely, Socorro's Director of Communications, and I will be facilitating and moderating the webinar. Socorro is hosting this webinar series to discuss, highlight, and raise awareness about coastal ocean observing activities in the Southeast U.S. Socorro is the regional coastal ocean observing system for North Carolina, South Carolina, Georgia, and Florida. We are one of 11 that make up the NOAA Integrated Ocean Observing System. Our mission is to sustain and promote observations that help keep you safe. This is a quick snapshot of the technology we support to accomplish our mission. And you can find ocean data at socorro.org. Here are a few Socorro opportunities/news. Since this is a hurricane webinar, we wanted to highlight our hurricane data resource page right here. We are working to become the go-to resource for quick access to all hurricane data for the Southeast U.S. We have over 23 resources available on this link here, socorro.org/hurricane-series or resources. Please explore it. If we are missing anything, please let us know. We want to be inclusive. And then the week of June 17th, we will be in Wilmington, North Carolina for our annual meeting. We are kicking off the meeting with a free public forum that Monday night, June 17th. Please join us at the University of North Carolina, Wilmington Center of Marine Science to learn how experts are utilizing data to increase our understanding of hurricanes and the changing climate. The next few days, June 18th and 19th, join us at our annual stakeholder meeting. It is a chance to network with experts and provide input on the climate and coastal hazard sections of our planning documents. Please register today. All right, let's get to the webinar now, the reason you are all here. As a reminder, all participants will be in listen-only mode. You are encouraged to type questions for the presenter or technical questions for me in the bottom right-hand chat box. I will respond to them directly or post the questions to the presenter after their presentation. We are recording this webinar today, and a recording of the webinar along with the PDF of the slides will be available on the Socorro website. We are very excited to welcome Steve Pass and Reed Hawkins from NOAA's National Weather Service, Wilmington, North Carolina. They will be presenting an overview of Hurricane Florence. Steve Pass serves as the Warning Coordination Meteorologist at the National Weather Service office in Wilmington, North Carolina. As the Warning Coordination Meteorologist since 2008, he is responsible for promoting marine weather safety outreach and awareness to the public. We also have Reed Hawkins joining us. Mr. Hawkins is the Science Officer for the National Weather Service Wilmington office. Steve and Reed, thank you so much for joining us. I'm going to go ahead and promote you both to presenter so you can share your screen.
Okay, thanks, Abby. This is Steve Pass, and to my left is Reed Hawkins, and we appreciate this opportunity to share a lot of our experiences with Hurricane Florence, and hopefully you can see our screen. Hurricane Florence. Can you see our screen, Abby?
I cannot see it. You might need to share it.
All right, let's see here.
Hit that, yeah.
Okay. Sorry about that.
No, you are okay.
All right. Okay.
Perfect.
Is it showing up now?
Yes,
okay,
you're
great.
good to go.
Great. Thank you. Yes, again, we appreciate the opportunity to share our experiences regarding Hurricane Florence. I've been at the Wilmington office now for 21 years, and just when you think you see it all, here comes a storm like Florence presenting its unique set of challenges and a multifaceted storm. When we look around at the impacts parts of southeast North Carolina had experienced with the full gamut of hazards, from just a prolific tornado-making machine the storm was, to a significant storm surge, the rainfall, historic rainfall, and pretty strong eye-wall winds. So we're going to look at all of these various impacts, put the storm in a little historical perspective compared to some of the storms we've had over the last few decades. What made Florence unique compared to the others that we've experienced before. And again, we'll look at the impacts. We'll look at the decision support services that we provided. We'll look at our operations, a little bit of a climate perspective, and then we'll wrap it up with some of the social science and issues that we have moving forward, some of the things we learned from Florence, a lot of the social behavior type things that we ran into. So as far as just a basic overview of Hurricane Florence, it's a Cape Verde to Cape Fear storm. From Cape to Cape, everything in between, but there were some unique things about its track that we'll look at. But as far as some, put it in context with fatalities that we had, there were 22 direct, 30 indirect, and for those of you that aren't aware of what's direct versus indirect, an example of a direct impact would be tree falls onto someone and they're killed as a result. An indirect fatality would be, tree has fallen across the road, 20 minutes later, someone's driving 60 miles an hour into it and hits it and is killed as a result. So that's the difference. Regardless, there's still a result of the hurricane. So over 50 fatalities as Florence impacted the southeast and moved northward. When you look at the financial side of it, it's $24 billion and growing. It's the 9th costliest on record. A lot more infrastructure in place with the big housing booms we've had since the 90s in this part of the country. So more and more of our infrastructure is at risk as a result. As far as rain gauge observations, we had a peak recording of just about 36 inches of rain near Elizabethtown, North Carolina. It's a little bit inland. We had multiple between 30 and 35, but what Reed will talk about with the radar estimates, I think will be pretty amazing to see. We think there was a lot more in some parts of our area of responsibility. We observed a peak gust of 105 miles per hour at the Wilmington International Airport. That's the second highest wind observation we've recorded. The first was Hurricane Helene in 1958, 135 mile per hour wind. So it was, and that was with the eye wall, the western part of the eye wall as it moved ashore. And then the rainfall from Florence, we actually exceeded our yearly rainfall in September as a result of Florence, and we ended up with 102.4 inches of rain. We're normally just under 55 inches of rain, so it was just an incredibly wet year. And so we had the spigots turned on, and now I think we're the sixth driest spring on record. So it's all or nothing on this part of the country, unfortunately. When we look at the fatalities, we had 14 storm-related deaths in our area of responsibility. 9 were direct, 5 indirect. And I'm not going to read through all of these, but you will notice that most are motor vehicle-related. People just swept off the roadway, people out and about when they shouldn't be, and it didn't matter. There were trucks, there were cars, just what we see time and time again. You go back to the 2015 historic South Carolina floods, and it was the same MO there. Everything is vehicular related. So we're doing well with storm surge. We're doing well with the other parts of the storms, but for whatever reason, we need to put a lot more effort into people driving during these dangerous flood events. We saw nothing different here with Florence compared to the past several storms that we've had. Of the 9 fatalities, there were 7 that were, they basically equate to 78% of our deaths were associated with vehicle flood type of things. We had 2 from wind, none from storm surge or tornadoes, and the tornado one was really shocking because we had dozens of tornadoes with this storm, but unfortunately no injuries or fatalities from that aspect of the storm. As far as the indirect fatalities, 2 carbon monoxide, 2 auto accident, 1 in our area of responsibility was a fall, someone falling off the roof making repairs, and we also had 1 suicide in our area of responsibility. In North Carolina, there were multiple suicides as a result of the storm, and there were several falls, people trying to make repairs, and we can talk about that towards the end with some things we need to think about moving forward. A little bit of perspective, where was Florence different compared to other storms? It was a Cape Verde storm. We've had many of those over the decades, but what was really unique as September 6th rolled around, the storm was at about 25 north, 55 west, and we typically see that sweet spot for our Carolina hurricane a little farther south in latitude, and then they make that turn around the Bermuda High and come right up the coast. But this one, when you look at analogs, so all those storms are at this position at their point in time in their life cycle. We plot all those previous storms, and only one of them back in 1988, it was a tropical depression that even came remotely close to impacting the East Coast. So this storm was in an area where no storm had ever had a landfall in the East Coast of the United States. So that was kind of unique in itself. We really had no past example to draw from regarding the climatological tracks. The other difference is for southeast North Carolina, the Cape Fear area, our typical approach from hurricanes is from a southerly direction, and this one came from an east to west track, which unfortunately brought the brunt of the right front quadrant directly onshore in the Pender County, Onslow County, and some of those east-facing beaches. So the principal track, what we typically see is from the south or southwest. Again, the storm makes the turn around the Bermuda High. This one came in right from the east. And the reason for that was this blocking high. This is 500 millibar pattern, and low pressure struggles barreling right into high pressure, so it tends to move around the periphery of high pressure. So we had this blocking pattern in place to its north that helped keep the storm on a westerly track, and then as the storm approached the coast, a new blocking high developed to its northwest, so it kind of got into a call, which is just an area of very weak steering. So when we were thinking the storm would originally come through 10, 15 miles an hour and track off towards the north, then the models picked up on this new blocking high developing, and then everything slowed down, and the Hurricane Center highlighted that trend in forward speed, and my goodness, at some point we had less than 3 mile per hour movement across our county warning area, which just added to the duration of the impacts that we're seeing. When we look at as far as what we typically see with storms moving through, it's generally 10 to 15 miles per hour. They're in and out of here within a day, and we start picking up the pieces. But this one, again, extremely slow motion. Just the contrast, Hurricane Hazel in 1954 was moving through at 30 miles per hour. But the amount of winds that we had, even though there were Category 1 sustained winds or wind gusts, the duration of these winds is the ground got more and more saturated. It didn't take as much wind to knock over the trees, so that just the duration of the storm over our area just led to a phenomenal debris management issue in the days and weeks following the storm, even months in some places following the storm. When we look at the storm surge, we don't like when we see the front right quadrant of the storm directly facing the shoreline. And what I've shown on this graphic is the effective fetch, which is basically the side of the storm where the winds are generally blowing the same direction the storm is moving. And when you add all these together, it's an effective duration. So every time the storm took a jog to the left, it just put the full front of this right front quadrant directly into North Carolina. So the effective fetch and the effective duration, we're fortunate that a lot of the peak surge occurred at low tide. Otherwise, I think we would have a lot more dune breaches and issues that we had. The other thing, too, with the amount of rainfall coming in with our storm surge, with the storm surge being held up along the coast, the onshore winds, and the amount of rainfall we're having, the waterways were particularly hit hard. Lots of docks were lost. There's water into homes on the mainland side as a result of this as well, and even up into Pamlico Sound and the Neuse. I mean, just days of onshore wind and that rainfall. Those river systems up in the sounds couldn't flow where they're supposed to, and it was just phenomenal storm surge up in the Sounds part of eastern North Carolina. Just a few examples. We did do some surveying with the National Hurricane Center, with the storm surge specialists and some of the other specialists, just to come out and look and see. A lot of beach was moved around, a lot of dunes. You can see in the top right picture, there was just complete dune loss. There were many homes lost on the ocean front, and there are many more in jeopardy now. The first of the sea turtles started nesting, and they had to stop the beach renourishment as a result. So heading into this hurricane season, there's some of these areas that are extremely vulnerable, which is of concern. In addition, the other antecedent infrastructure issues we have, there's still hundreds of people with damage to their homes, a lot of tarps. You fly out of the Wilmington airport, you see a lot of blue tarps still in place. There's still people displaced. We're just going to have to deal with these as we move into the guts of this upcoming hurricane season. We look at even the Cape Fear River. You would think it would be river flooding that gives us our highest values. It's actually storm surge. It bottles up the river that we see our record flow with these. And some of these water levels, and you can see just it displaced for several tidal cycles on that lower graph there where we have issues. And then eventually the riverine flooding, the flood waves came down weeks later. But just the amount of water being held up in the Cape Fear River trying to flow out just bottled up and caused issues downtown Wilmington and some of the low-lying areas on the lower reaches of the Cape Fear. And when I looked at the Hurricane Center's report of the storm surges, generalized values in here, the Onslow Bay cusp there in orange had 5 to 8 feet AGL, and that does not account for the large breaking waves on the oceanfront side from that. So it's just basically just the AGL rise, the water levels, and you look up in the Neuse and some of the other estuaries and more complex systems up in the Sounds, 8 to 11 feet AGL was observed. Fortunately for Long Bay, our northeast South Carolina coast was on the more favorable side of the storm, so the surge was generally lower there and the impacts were less. It's all about that right front quadrant. In addition to the shape of the coast, the bathymetry, the astronomical aspects, it's very complicated issues that we deal with here, especially up in the Sounds.
Okay, thank you, Steve. This is Reed Hawkins. What I'm going to cover is the remaining impacts that we had during Florence. As you can see here on the screen, we have the Hurricane Florence. This is approaching Wilmington near my cursor. You can see it looks kind of ragged. The eyes cut well open, especially to the northeast. Still pretty strong to the west. But then you look to the right screen, you can see that it looks like it's tightened up and it's become more well developed at the eye. And what we saw with that, with the high winds, that's when we saw the peak gusts here at the Wilmington airport at 105 miles an hour. And here is a loop of the radar. And at first it's going to come through, it's going to be slow, and then we'll go through it fast. But you can see it's approaching that high pressure. There's a weakness in that call that Steve talked about as it starts moving towards, looks like Jacksonville. And then all of a sudden it starts moving a little bit farther, more directly to the west because of that building high pressure over the middle Atlantic, the Ohio River Valley. And as you can see, it's moving very slowly as it's coming through, and you can see those orange and yellow bands coming in there, producing very heavy rain, especially up to our north. We get the eye wall is now coming to Pender County, which is in this location. Can't use the cursor on this. And you can then you see it start walking down the coast to the southwest, and then it moves across Brunswick County into northeast South Carolina, and then it actually continues dropping over towards Columbia, South Carolina, before it starts turning to the north once that high pressure to the north moved off to the east. And then we should have it in faster speed on this second part of this loop. So I'll just let you watch that.
There were water temperatures in the upper 80s as the storm approached the coast. The Johnny Mercer Pier at Wrightsville Beach. I mean, there was a lot of fuel for this thing to work with right near the coast.
And here's the faster trajectory. You can kind of get a more feel of the actual motion. But you can see as it starts filling the coast, there's some convergence along the coast, which really intensified the eye. And then we talked about it was moving less than 3 miles an hour, and it just pummeled the area with rain. And these bands were also producing tornadoes, and we'll talk about that in a minute. Here is the wind gust. You can see, let me get my cursor here. You can see up here Wilmington 105. From Secor people, you can see out here the buoys we have. We got wind measurements from there. Also, I got ocean wave heights to help us prepare to know what was coming, the strength of the storm. You can see we've got 50, 60 knot winds, mile per hour winds down in South Carolina. But the strongest winds were definitely 92 up in Pender County, 77 up towards Jacksonville, but in that right side of that eye wall as it was coming through. And that this is the track, and then the isoplasts are of the wind speed, of the gust. Now here's a chart showing the red line on the left is the pressure trace, and the little scattered dots are the peak wind gusts, and those are from 1 minute winds that increase. You can see here at the top, that's the 105. It was kind of an outlier, but you can see how if you go from about 60 miles an hour, you can see from about 3Z, about 9 hours of winds over 60 miles an hour at the airport. On the pressures on the right, you can see the lowest pressures measured here in Wilmington since 1871. We've been fairly close, our instruments, since after World War II, when the measurements were taken here at the airport. Otherwise, they were from downtown. But so the only one would be the 32 hurricane that would have been measured downtown. But it was the fourth lowest, and the center of the eye really didn't get over the airport, so it probably didn't quite measure the lowest pressure. Now, here's some of the impacts of the wind. Typical, we saw the convenience store, their awning over their gas pumps fell. We saw many of those. We had this older building, which you saw the roof removed off of it. Really kind of hard to tell if that was a tornado or not, but I believe that's in the Wilmington area. And then this is actually just showing some trees. This is actually the same house, but showing multiple pine trees. And you can see they're all in the same direction. So that was probably straight line winds. Impact on tornadoes. We issued 35 tornado warnings. If you look in the right screen, every one of those red boxes there are an individual tornado warning that was issued during the storm. That's the most number of tornado warnings we've ever issued with a tropical storm, and that's in the modern radar era. That's just with the NEXRAD, which was in 1994. I always consider the radar as a modern radar era from the NEXRAD, kind of like baseball, the dead ball era versus the home run era is how we break that up. But we were able to verify 19 tornadoes. 14 of these were EF0, which are the smaller ones, very short-lived, probably didn't last very long, and, very small path. And we had 5 storms, EF1, with the highest estimated wind speed was 105 miles an hour. One thing we found out, it took us multiple weeks to survey this, which is really difficult. We had a lot of problems, especially with the eye wall cross, trying to get stuff with what's straight line, what's not. And as a hurricane goes with the eye, the wind's switching direction, so it was really a challenge. Other challenges, especially farther back inland, in these areas back here in Bladen, Columbus, Horry County, we couldn't get to them because we were flooded, and it took us several weeks just to get out there. And my guess, if we really had the real truth, we probably had more than 19 tornadoes. We just couldn't get to them or just couldn't determine because of the way the damage was. This was, if you look on the left, is a picture of a low-level rotation of these storms as they're moving on. And the MRMS is the multi-radar, multi-sensor system developed by the National Severe Storms Laboratory out in Norman. We use these a lot, some during operations, but we also use these a lot during our surveys so we can actually see where possible tracks of the tornadoes could have happened. And this was during we issued 18 tornado warnings north of Cape Fear, which is here, in an 18-hour period. And if you notice right at midnight, we had 5 circulations. This one went just, I guess it was Ogden, just went north of the airport here. This one you'll see, this one probably went across, if you're familiar with Wilmington, it's near Market Street and probably 23rd Street, just south of our office. This one, I'll show a little later on. This is probably one of our strongest storms that went near Ashley High School in southern New Hanover County, and then these 2 other ones to the south. But this was a really intense, about 5 to 6 hours, and we had 2 meteorologists that had come in to help us to supplement the staff that were just continually issuing warnings and flash flood warnings during this time. This is the southern New Hanover one. If you look, this is a 4-panel. Radar reflectivity is in the top left. We have base velocity, it's showing the way the winds are moving. I'll explain a little more in a minute. In the top right, we have what's called a tornado detection signature, which is actually showing debris lofted up using the dual pole, the correlation coefficient product. And then we also have what's called a normal rotation, or just showing a value of the rotation or spin of the storm. So what we see in the top left reflectivity is kind of a hookish area. You can see the flow is coming in this dryer where the green is, and it's coming around and kind of pulling back in here to the west in that top left. In the top right, the winds, you see the red winds, which I'm pointing here, those winds are blowing away from the radar toward the northeast, and then the blues are actually coming towards the radar, so you have this spin here, and that is real tight. That's a tornado vortex signature, indicative of a tornado, and if you've been watching the television the last few weeks, you've seen a lot of these signatures out in the Midwest. But typically for a tropical system, these storms are not as tall, they're not as big, and they don't last as long, but they can produce usually below EF1 or EF0 damage. And when I say they don't last long, probably less than 10 minutes, 5 to 10 minutes, and that's probably on the top end. And I said this TDS, that's just debris going up. That could be pine straw. We didn't have any house damage, but a lot of times you see this and it really comes illuminated when you get the insulation out of some kind of building and it gets water on it, and it really reflects big back onto that. So that elevation is about 1,000 feet high. The depth of this whole circulation, I didn't show it, is between 3,500 feet to 5,000 feet, almost a mile high. And that's you'll see this about double that in the plains with the big storms out there. And now we'll go to the rainfall, which Steve talked about a few minutes ago. You can see this is what's called a multi-sensored product, and this is from the MRMF, and it's using radar data, gauge data to make corrections to the rainfall amount. And this banding we saw from the loop, you can see all the way up from north of Jacksonville, Cape Lookout, up near the Hatteras, all the way down almost into South Carolina. You can see the purples, which are 40 to 50 inches, and this is where Steve was talking about, that we don't have any gauges, so we could measure it. The Elizabethtown gauge is about right here, even though the radar did not see that amount. And that may be because our radar was down for about 16 hours. And what happens is the radar up here in Morehead City, Raleigh, and Columbia are seeing the same storm, but they're shooting well above it, and so they don't really estimate the rainfall very, very well. Now, we'll go with our rainfall forecast changes during the event. On Saturday before the storm, this is our 5:30 p.m. Briefing to our core partners, and you can see the track on the left, and it's showing the hurricane making that curve, and it's coming right into the Cape Fear, southeast North Carolina area. Now, this is how you'll see how it changes, because the models aren't really, you can see right now, the models aren't anticipating that high pressure ridge building over the Ohio Valley. And you can see the rainfall totals here at this time are like 10 to 15 inches up to 20. And the reason why they're lower here is because they think the storm's going to be moving faster than it actually did. We go to September 9th. You can see almost the hurricane has shifted up a little farther to the north. You can see the M here, which means major. They were still thinking to be a Cat 3, Cat 4. It becomes a storm as it reaches the Raleigh area. But the rainfall totals, you can see now, we're just 15 to 20 still, but you can see it's kind of shifted a little farther north into North Carolina and Virginia, which is still showing that high pressure ridge not being modeled well. Here's the 10th. You can see it's now shifted even farther north, closer to Jacksonville, Cape Carteret, up in that area, Morehead City. You can see we're still on the 15 to 20. They still think it's going to be moving well. Probably a lot of more heavier rain up in Virginia as it slows down as a depression. Here we go on the Tuesday the 11th. We see a change. Notice it's kind of now, it's showing that high as the track is now bending a little bit farther back to the west. You can see now the totals looks like they're now over 20 inches. Problem with this scale, it only goes greater than 20. So you can see that's a challenge. A lot of these maps will put on there what they believe the maximum value is going to be. Wednesday, you can see now they got the forecast on Wednesday. It's now showing the curvature on the coast and then over towards Columbia, then farther back to the north. We're still 20 inches, but I think at this point we're at 40. We're saying 30 to 40 inches, even though this graphic only says greater than 20. Those are in our DSS briefings to our partners, so I think everybody knew we were in for a historic event. This is the noon briefing. This was just a valid rainfall total. You can see the track as it's coming across, still kind of showing the dip. It's more almost straight line, and then as that high pressure finally breaks down to the north, you can see it curling back. Now, let's talk about the historical flooding impacts. This map here is, this river here is the Cape Fear River that I got my cursor going down. To the east of that is the Northeast Cape Fear River, and they merge right here in the northern part of Wilmington to the south. And what we also see here is the distance between the Cape Fear and the Northeast Cape Fear River is about 1.15 miles, very, very narrow. Later I want to show this picture. This is a coal ash pit that Duke Energy has from an old coal power plant. It's been converted to natural gas now, but I'll show you an image of that. And this 421, Highway 421 here, used to be, before 1990, was the main path or highway into the north of the area. This went up to Raleigh. And far off the map to the east is Interstate 40, which is our primary route now. And of course, that was flooded and closed. And if you wonder where this area is, you can see the star on the map where that location. Now, last time that this Highway 421 was breached was in 1945. It was called Hurricane 9, the Homestead, Florida hurricane. And Rick Newhertz found this picture, our hydrologist who's here, and you can see from the Department of Defense, you can see where the water breached the highway. And at that time, I'm believing it's probably only a two-lane highway in 1945, but it's going from the Northeast Cape River to the Cape Fear River. So I'm sorry, Cape Fear River to probably the Northeast Cape Fear River. And this is about 6 miles northeast of the city of Wilmington. Now, this is what it looked like after the storm had moved out. What was going on here is it's two-lane roads, 4 lanes total, and there's culverts that go underneath this, large culverts, and it washed those out. And you can see how it just totally cut this road off. And Interstate 40 at this time was completely cut off, so we had really very few limited choices of how to get in or out of the area. This is a picture I believe Steve took, or Carl Morgan, and this is actually the water running across 421. It's going from left to right, from the Cape Fear River to the Northeast Cape Fear River, and it likely helped displace some of the floodway in the Northeast Cape Fear River and causing less riverine flooding for downtown Wilmington. The good news is I'm very happy the North Carolina DOT decided to build two-lane bridges and remove the culverts so there would be more flow underneath it. And they did this decision was made pretty quick compared to what normally would go on. And right now I believe they have one temporary bridge going across the highway now. This is downtown Wilmington. On the left, if you can see, that's the USS North Carolina Memorial Battleship. And this is just the river walk. And you can see, especially during tidal plus our freshwater flooding, you could see at times of high tide, it would flood up on the river. And here's someone who didn't turn around. Hopefully they didn't drown. And on the right is that coal ash pond near the power plant. And you can see how the Cape Fear River has just flooded that and moved out. Really don't have any idea how much coal ash got into the river. And so that was another environmental disaster there. On the left, these are areas to the south of Wilmington, which would be down in here. This is the US 17, the highway from Wilmington to Myrtle Beach. You can see how it's completely flooded. And just south is NC 904, another smaller highway, completely flooded as you're going into Brunswick County. The top right is actually just near Wallace, and that's Interstate 40 that looks like a canal. And that is a I'm guessing a hog farm or a turkey farm that's completely flooded. And then after the waters fell back, you can notice we saw this many places where just huge numbers of fish were just littered across the highways and in the grassy areas. And I do know that some of the volunteer fire departments were used to use their hoses to wash them off the roads. And it was just horrendous. Now this picture's a little, if you look on the left, this is Marion County, which is inland southeast North Carolina, northeast South Carolina, here where the star is. The picture on the left is Nichols, South Carolina, and this was in 2016 near Matthew. You can see flooded. Well, what happened in 2018? Nichols got flooded again. This is like the second, third time this community's been hit. There's many other smaller communities, and a lot of people haven't rebuilt, and a lot of these areas are dying. People were moving out anyway, but now this just really hit what left was the economy of the farming communities extremely damaging. This is Interstate 95 bridge over the Lumber River. On the left is Matthew, 2016. Steve and I actually walked down there. We were over there and almost got stuck because of the flooding. Not one of our smarter moves, but we didn't drive it in. We walked. There's an overpass closer to us. And then in 2018, you can see here it is a repeat of flooding the highway. And there were a lot of people who were coming up here in 2016 trying to get to Florida, and they had no clue how to get back. And what happened was the Cape Fear River north in Fayetteville closed the freeway up there, so there were a lot of people stranded in this area. This is Conway, down just outside is the county seat of Horry County, which is Myrtle Beach. You can see the Conway, the city marina, is flooded, taken by some of our, I think, probably from some of our helpers down in Charleston that came up to do some storm survey. In Saskatoon, South Carolina, which is a little farther south, you can see where this is the Waccamaw River in Horry County that flooded. And this is a very slow draining river, and it was over a month before this thing got out of major flood. Impact historical flooding, as you can see, this is all our river gauges. The ones that have the solid red stars are the all-time record crests for those river gauges. The ones with the blue, you can see down south, that was the all-time crest was in 2015. There was a big, giant, heavy flooding event in 2015 that went more to Charleston up here, up over to Columbia. 1945 was that Hurricane 9 that hit that hit those areas inland. For some reason they didn't peak. During these over here in South Carolina, they just didn't get as much water. But it was interesting, the Cape Fear River didn't, especially upstream, I guess the water didn't make it up as much there. So that's where those had fallen. And now I'll turn it back over to Steve for operations and the decisions.
Okay, great. Thanks, Reed. As many of our partners and media and with emergency management, everybody's extremely busy putting in a lot of time before, during, and after the storm. But we were short four total people, but we were augmented by staff from other weather service offices. So we had staffing issues to deal with. We also had, afterwards, doing the riverine surveys and also the storm surge surveys. We had 2 hydrologists and 2 forecasters help us with those. We had to go into backup mode for a couple days as well, just so our staff can go and check on their homes and make repairs that they needed to do. But overall, we were at the office, everybody at the office, for at least 3 nights. I was here for 7 days, just trying to make sure we get seamless operations going on. We did have a lot of people just donate us food. We don't know who just showed up on the front door, basically. So it was great that people were thinking of us and sending their well wishes. But just crazy operations for many days afterwards. Our hydrologist, I think he ended up working like 19 days straight, given the duration of the river flood event that followed everything here. And I know this is a busy slide, but just shows our pre-storm decision support and the direct impacts of the storm and post-event recovery river flooding side. Our first briefing went out to our partners on September 6th. Remember, landfall was September 14th. We have 2 states that were responsible for us. We had 102 conference calls amongst the 2 states. We led 17 of the calls. We had dozens of media interviews, I think over 50 of them, including national feeds, CNN, NBC, a lot of live radio. We issued 28 briefings overall. But when we get into the direct impacts part, we had, again, the full gamut of impacts from the storm. The initial impacts and initial flood briefings went out on the 13th. So even though it's a day before landfall, we're looking at the riverine aspects of this for the post-storm aspects. Then we had landfall, eye wall winds, a storm surge, flash flooding on the 14th. Tornadoes, more flash flooding and surge continue on the 15th, flash flooding, riverine flooding on the 16th, and then really getting into the river flooding on the 17th. And our last briefing was on October 5th, and we finally got a little bit of a pause and then had to begin ramping up briefings again for Tropical Storm Michael at the time as it moved through its some impacts on October 11th. And this is just an example of one part of our briefing. We do an impacts matrix based on the level of impact and then the confidence associated with that. Again, when we think of hurricanes, we think of the Saffir-Simpson scale and just the wind part of that. At least the public just focuses on the wind part of that. We try and display all the various impacts and get people away from that scale in terms of what impact is relevant to them. And this is a tool we help convey this to our partners and then begin a unified message for the expected impacts. Just as an example of our river briefing that we did for after the storm, this is for Waccamaw River near Conway. We talk about the impacts based on the level of the forecast that is expected with a little synopsis. I know it's a real busy slide, but a very useful slide to our EM partners who look for this information in making their critical decisions. We are also supporting stand-up briefings for a NATO exercise that was embarking from the Port of Wilmington. So it was Operation Trident Juncture. So if it's not hard enough as it is, now we're supporting a major military exercise with the European connection. But that went really well. The state ports and Coast Guard liaison was very pleased with the work we provided and helping them decide when to go, when they can do so safely. And we're pleased to see that everything went off without a hitch before that. So it was just another big DSS challenge that we had. Just some other examples of DSS. New Hanover County Emergency Management, we supported them directly with the timing of the eye wall, so they can respond to over 300 911 calls that came in as the west side of the eye moved through. As a result of our information, they were able to triage the most life-threatening calls when they could do so safely. So we, just a specific example of where we can add value to the response, and in this case, providing the eye wall timing over New Hanover County. We helped with U.S. Coast Guard vessel diligence with river level information. They can make it up the Cape Fear River and dock downtown. Darlington County supporting scope for a potential dam break. We supported the Brunswick nuclear plant with timing intensity of winds with Florence for their operations. I mean, I can go on and on and on with these. Lumberton providing river level information so they can protect the vulnerable area that floods parts of Lumberton. And just a few examples. As far as some of the feedback we got, just real quick, wanted to plug our hydrologist, Rick Newhertz, who has done a phenomenal job. He was provided information to a member of the public whose family member was in harm's way, and then so he gave her this information about the danger her dad was in. And then a little bit later, a few days had passed, and she received the email from this family member, and basically, the rescue group came and got her dad and the 2 dogs out. I can't thank you enough. Now just praying for no more storms. Thank you. Without your email, I would never have been able to convince him to leave. You're right, the water is rising as the big PD is affecting the flow of the little PD. Bless you. So it's just, the DSS extends to the public as well in what we do in our mission and trying to help people get out of harm's way. And as far as the Atlantic Multi-decadal Oscillation, just real quick, wanted to talk about this. extremely important background pattern that goes on. It's periods of above normal Atlantic basin temperatures and periods of cooler than normal. They're 20 to 40-year periods. The last warm phase we're in, we're currently in it, started in the mid-90s, and that kicked off Bertha, Fran, with Bonnie, Floyd, Irene, and on and on and on. Fortunately, it looks like we're on the downward side of this warm phase, but we typically see extreme hurricane activity, our heat, we get record heat, and during the cold phase, we get a lot of our winter weather events. And we can have hurricanes during these cold phases. 89 was Hugo. We don't let our guard down regardless of the phase, but it's interesting how a lot of these peaks are coincident. When you look at the 5-year averages, the black line is the annual tropical cyclone count 5-year average, and they tend to match nicely with the warm and the cold phase anomalies out there attributed to the AMO. Again, it's just one piece of the puzzle. There is no silver bullet to hurricane predictions. There's many, many things involved. El Nino, the Saharan air layer, and even week-to-week or day-to-day changes can have an impact on formation and who gets what with these. But the Atlantic Multi-decadal Oscillation, I think, is a very important part to that. We've had 6, the quote-unquote 500,000-year flood events since 1999 that began with Hurricane Floyd. There certainly is something going on that is what was anomalous events is now becoming the norm, especially with the flooding events. And you can see 6 examples up there, some directly attributed to hurricanes and others attributed to just moisture feeds out of the tropics. And we're not alone in these big events. You know, Hurricane Harvey a couple of years ago, over 50 inches of rain in the Gulf Coast. These anomalous events are becoming the norm, it seems. So it's just, you know, really dangerous times that we have given the risk that we face. Hurricane forecast challenges, again, my main point is everybody focuses on the wind speed. Everybody's focusing on the Saffir-Simpson scale. It's not just about the wind, and unfortunately most people decide to evacuate or what their tolerances are based on the wind and not these other aspects when it comes to personal decisions. This is from Gannon Medwick with WECT. He let me use this. It's just a great example of the perception of this. The Saffir-Simpson scale covers just that one aspect on the left-hand side there, the green graphic, maximum wind, whereas the other elements of the storm not covered by the scale, from the gusts, the tornado threat, the rainfall threat, river flooding, storm surge, a whole litany of items that we have to really contend with, and the picture that we want to paint regarding before that storm arrives so that people can make the best decisions they can. We've got to get away from this Saffir-Simpson scale. It's more to it than just the wind speeds. And I think just the last points that we want to make, we always learn new things when it comes to these natural disasters, and we do a good job at planning for short-term type events. But this one, these long drawn-out events, we find a lot of people are not prepared to handle that. We need a set of guidelines for slow-moving storms as well. Understanding that evacuation is not just with the Saffir-Simpson scale, but it should be relevant to each individual with respect to the unique risks that they face. They live in an area with 40 trees where they can come crashing down. Do they live next to a tidal creek that can flood? There's so many other things than just storm surge or just the wind where we see our risks. And there are many ways to die, as I showed you in some of the examples, many ways to die or become injured before, during, and after a hurricane. And, I really think we need to take a closer look at our messaging. After the storm, you've got insurance agencies saying secure your homes, put tarps on the roof. So now you're telling people who are untrained to go on their roof, to climb up on the roof and make repairs. So it just seems counterintuitive, to the actions that we expect of the public afterwards. They put themselves in harm's way trying to address things that they're not trained to do, which is one aspect of that. Need to plan better for what we haven't experienced before or what we haven't seen in a very long time. Hurricane Hazel is a perfect example, when that comes back, a variant of it. Need to focus and consider more on mental health issues. Like I said, the PTSD in this area is very high as a result of the storm. There was a lot of normalcy taken away from the public, and there are a lot of people still suffering as a result of that. And people need to understand that if they're not going to evacuate and have a medical emergency, rescue is not likely, and it won't be likely until the area remains becomes accessible again, and we lost people with medical emergencies that couldn't be rescued as a result of the strong winds and the flooding. So I think that's all, Reed and I have. I guess, Abby, we'll turn it back to you to handle the questions.
Yeah, thank you guys. Thank you for the great presentation too. And I'm going to go ahead and leave your presentation up in case somebody references a slide. And I also just want to thank you guys for all that you do to keep us safe and informed, not only during a storm, but every day. I can't thank you enough. And that quote with the lady with the PD River, that really hit home. So thank you guys. We have one question from Eric Hatcher. The river DSS products with USGS rapid river gauges were disseminated by senior hydrologist Rick Newhertz as an HTML product that could be added to desktops as a shortcut. This product greatly aided us in a decision to evacuate a facility. Question is this a common product that other National Weather Service forecast offices have and can disseminate?
And for Eric, I mean, we've got Rick Newhertz here. I'll let him address that. I know he built it to help our local partners. You hear of any other?
Well, that idea is one I actually got from somewhere else and tailored it to our area. So the HTML situational awareness thing Eric's talking about is something that I, for lack of a better word, swiped from some other National Weather Service office. So yes, other Weather Service offices have it. I don't know if anyone else thought about emailing a simple HTML file out to everybody else to use. They could do it. Simple enough. So I guess the short answer is yes, it could be done. And yes, some places have it.
Great, thank you. And if anybody has any questions, you can type it in the Q&A box or the chat box on the bottom right-hand side. I do have a quick question. So you guys said the storm was pretty slow and storm surge wasn't the biggest damage causer. And so does the position of the eye affect storm surge?
Yes, definitely. I mean, we call it with the eye, the strongest winds, the radius of maximum winds, attributed to the eye wall. So anywhere you have that eye wall nearby, or usually to the front right side of its motion, is where you get that effective fetch really pile on. So you'll get a displacement just from the pressure with the storm, the angle of approach to the storm, the bathymetry adds to the storm surge. So potentially greatest loss of life is from storm surge. But when you look at the statistics, if you take out Hurricane Katrina and go back to 1970 and look at all landfalling storms, most of the fatalities are inland freshwater flooding. But there's a lot of loss to the infrastructure as a result of the surge. You get high water levels well inland. A lot of people think it's just an oceanfront issue. But yeah, anywhere in proximity of that radius of maximum winds and on the right-hand side. So you can get storm surge well away from where the storm makes landfall, or even if it stays off the coast. So I mean, that's why I think it's great that the National Hurricane Center has storm surge warnings to kind of highlight that risk from your traditional hurricane warnings.
We've also even seen storm surge on the lake when storms come ashore. Lake Marion, there was a surge that the water level came up on like the east side of it with Gaston, I think it was, and there were some issues with structures and such down that way with that one.
Yeah, Lake Waccamaw also, with seiching even as a result of the wind. I know Hurricane Hazel, and we even had reports of seiche in Lake Waccamaw in the county to our west with Florence.
Wow, thank you.
Hey, Abby, it's Jennifer Dorton, and I'm going to ask a question since I'm actually in here with the Weather Service office folks. I know that it was several days out, you had started really pinpointing the storm path, and y'all could see exactly where, those several days warning where folks really knew, hey, look, this is coming. At what point did you all start realizing, hey, the storm was slowing down and disintensifying, and what do you think you guys still need observationally to start getting the intensity piece of the storms, I guess maybe known sooner, if that's a way to phrase that?
Well, Jennifer, the hardest thing in hurricane forecasting is the intensity. And I don't think we had any idea that it was going to weaken There must have been some dry air or shear that got into the storm at 24 hours out, which helped weaken it. It also could have been an eye wall replacement. There's just all these theories. Probably there may have been some kind of shear in the eye wall replacement, and then it became so big that the eye that it has a hard time re-intensifying as it's getting closer to the coast. So that was the biggest thing. Once we saw that high pressure, the models, the European model, also the American model, the UK Met model was showing that high pressure ridge building to the north, and that was probably 48 hours. It was starting to go, is it really going to go south? After you see several model runs of it happening, you're getting a little more confident that it's not just an outlier and it pops back in.
One of the previous Weather Service directors, it resonated with me when he said it, if you can measure it, you can manage it. So, I mean, it's all about observations. You can have the best weather model in the world, but if you can't feed it observations, it has no starting point. So, and that's always very difficult out over a maritime area. That's why we're so aggressive with the Hurricane Hunter missions and the Gulf Stream, the P3s, the United States Air Force. I mean, it's in an area where you don't get a lot of weather data, and that's a big piece of the puzzle. So the more observations that are out there just really help the process. And then when you get a storm approaching the coast like this, again, that initial line of defense that we have Doppler radar, we have satellite, but that initial line of defense are buoys that give us real-time information, and we can understand what's happening quickly as it's unfolding.
Probably the two biggest things, for the most accurate, are the buoys and the hurricane reconnaissance. Satellite's good to a point, but to actually get a verifiable wind speed through the drop signs from the hurricane hunters, or if it's near a buoy, even those farther out in the ocean, very, very important to help us try to get an initial reading on what the storm is, if it's intensifying or weakening.
Great, thanks guys. And we have 5 questions. Are you okay to hang out to like 102 or 105?
Yeah.
All right, cool. Is there a move to improve the Saffron-Simpson scale or change to a more impact-based scale?
I think as we work, I mean, we have great partnerships with social scientists, across the agency, and I think there will be a move towards that. But I mean, we're kind of seeing it now, like what the National Hurricane Center did with Hurricane Michael. Since the wind was going to be a really big part of it, there's no problem referencing the Saffron-Simpson scale then, or like when Florence was expected to be a major hurricane. But when it looks like that's not going to be as much of an issue as some of these other the other impacts that we see, they kind of don't highlight it as much and get back and focus on the impacts. Kind of like our matrix there: life-threatening flooding, deadly storms. We try and paint the full picture and not the one part. So there is a use for the Saffron-Simpson scale, but it shouldn't be the end all to everything when diagnosing these. So I think as we move forward, how we message is important. And Florence was a great example of that with the Saffron-Simpson scale, because if you message it the wrong way, so when it moved on shore and weakened, the actual impacts were going up with flooding and tornadoes. So it might give the impression to someone in the public that, well, I'm going to head home. The storm's now down to a tropical storm. Well, they're heading home when the other impacts are actually increasing. So messaging, working with social scientists, are key to this. Whether we get into some sort of involved matrix like I showed you in our briefing or not, it remains to be seen. But we're not going to do it in a vacuum, that's for sure.
Yeah, I really liked that matrix. I took a screen grab. There was a lot of damage to UNCW. Was that due to a tornado?
I think most of the damage, talking with our EM partners at UNCW, I think most of the damage was from the eye wall, and also just flooding onto the roofs of these buildings. So, I mean, I don't think we found any tornado damage at UNCW. We did have access to that part of the county in the weeks afterwards. So I think a lot of the damage we saw to the trees, tree-related and wind structural stuff was from the eye wall as it slid across.
Great, thank you. Did any data gaps or gaps in needed partnerships come to light as you were working through the sustained event?
Well, the biggest one we had, and it's not really much we could do about it, is our radar was down for 16 hours. And the reason it was down is due to communications, which I've been here for 26 years, and the communications are the weakest part of what we have due to the phone line. It's better than we used to have, but we were down for 16 hours for that. And so we were using surrounding radars, but they're so far away that we're measuring higher in the storm. I guess we could always use more marine type observations. We're actually pretty lucky compared to some places on getting those. I think we pretty much have a good surface observation network with the government instruments, and then also a lot of people, volunteers, have their instruments and they're actually out on the internet, and we can get some wind speeds out of that.
You know, I think another part too is when we talk about building our resiliency, we need advocacy in all corners and look for non-traditional partners. And we work with the EMs, we work with the academic community, but there's so many opportunities out there to help build resiliency, and as many advocates we can get for that. I mean, we've got the best technology, we've got the best research going on, yet people are still dying, so that tells me the missing piece is, along the lines of awareness and preparedness. And we get so many people moving into our area, we can't just stop talking about hurricane safety and what should people do. It's always going to be an issue for us, and that educational component is there, and that Weather Ready Nation program, becoming an ambassador, will help us spread the word. So if there's any groups listening that would be interested in becoming a Weather Ready Nation ambassador, I mean, please let us know. Help us become a force multiplier.
Great, thank you. And Socorro is proud to be a Weather Ready Nation ambassador. A lot of great resources to share. Somebody is not certain what MRMS is. Can you please review that?
Yeah, that's called the Multi-Radar Multi-Sensor System, and it's what it is. It's just software that takes the available data that they can estimate. When it was originally developed, it was developed quantitative precipitation estimates, rainfall totals, and it's using all the radars. It's using gauge information, and what it does is it mosaics it across the country. And what it really helped us on is when our radar went out, we became a whole. There's no data there, so it was using the surrounded radars around it. Besides just the QPF part, it actually will give us hail tracks, which we can use if we have to go out and do surveying. We can actually see this in real time, so we can see, okay, there's possibility of hail. If we want to continue warnings, you can see the rotation. There's also some lightning information. We can actually determine if storms are becoming intensifying or decreasing, maybe becoming severe due to their lightning activity. It's pretty important piece of software that we're getting, and it's been they've been developing this thing over about a 15, 20-year period.
Great, thanks so much. Do you guys have time for one more question? And all the questions that we did not get to, I will email you all separately and connect you with the person who asked the question.
Okay.
All right, a lot of storms weaken as they come in here. Do you look at oceanic heat content as a factor in the storm intensity?
Yeah, we do. I mean, it's a big part of that, and having buoys with sea surface temperatures, and even if there are some ways to get a profile of temperatures, it's very important. I know there was a storm in the Gulf, Opal, I think, that went from a category 1 or 2 to 4 as right before it made landfall, and that heat content was a factor in that storm's intensifying. But also looking at conditions over land, if there's a lot of dry air over land that can entrain into the storm, is equally important to determining or not if the storm might weaken. So it's we're looking everywhere for data to determine whether or not the storm has a chance to intensify or weaken.
And with that dry air Steve mentioned, when we get all these, most of our storms come from the south or southwest, southeast. A lot of those pull in a lot of dry air, and they weaken it, and they sometimes can intensify the eye wall, like we saw in Hurricane Florence. It was intense all the way from Wilmington up to Raleigh. But this one, because it was almost coming in perpendicular, it didn't really ingest any dry air.
Great. Thanks so much. And Katie Tomberlin and Charlton Galvarino will answer your questions over email. Sorry we could not get to them. I want to thank everybody so much for joining us, and thank you, Stephen Reed, for presenting. This was a great presentation. A recording of the webinar along with the PDF of the slides will be available in a week, and we will email everybody that link who is registered.